In this video, we're going to take a look at inscribed angles and old information on arcs, as well as kind of tying in some isosceles triangle theorems as well. So we'll start with that. The isosceles triangle symmetry theorem says that the line containing the bisector of the isosceles triangle, or basically the perpendicular bisector of the base, is the symmetry line for the triangle. So this side and this side would match up perfectly if we folded along this line of symmetry. And the base angles we already know are congruent, but this vertex angle would be bisected, so that half and this half would be congruent. Okay. The definition of an inscribed angle, let's talk about that briefly. An inscribed angle is an angle that whose vertex is on the circle. So in this example here, the vertex of the angle is right here on the circle, and the angle goes all the way through and comes out at those endpoints. So this is what's called an inscribed angle, which is not to be confused with a central angle, which has its vertex on the center. Both the inscribed angle that was originally drawn and the central angle that I just drew open up to an arc that measures 56 degrees. What you should remember from Unit 1 is that central angles are equal to or equivalent to the arc that they intersect, while the inscribed angles are half the measure of the arc and half the measure of the central angle opening to that same arc, since both of those are the same. So if this arc is 56 degrees, what is the measure of the inscribed angle? Go ahead and pause the video and try this question and push play once you think you have the answer to see how you did. 56 degrees divided by 2 is 28 degrees. That would be the measure of this inscribed angle. Thales' theorem talks about if a inscribed angle intersects a semicircle, then that angle is 90 degrees. And that's really just a specific case of the inscribed angle theorem, which, since this is opening up to a straight angle which measures 180 degrees, the inscribed angle would be 90. And it does not matter where that vertex angle is, as long as it's on the circle, it's inscribed. The part that matters is what is the angle opening up to, what arc is being intersected. Here this arc would be 90 degrees because the central angle is 90. And so all of these angles, regardless of where the vertex is around the circle, would be 45 degrees, as they are half of 90. Even if the angle opened like that, line is not very straight. Let's see if I can do it any better. That's a little better. This would also be a 45 degree angle opening up to that 90 degree angle. So the vertex does not matter where it is as long as it's on the circle. It's the arc that is intersected that matters. In the next examples we're going to look at, there's 5 of them. They will progressively increase with the difficulty level. What I'd like you to do is pause the video, try each question. When you think you have the answer, or if you feel like you've gotten stuck and you're not really sure where to proceed, go ahead and hit play and see how you did. In circle Z, the measure of angle ZXY is 31 degrees. A lot of students confuse that as angle Z right here, but when there are 3 letters being used to represent an angle, we start at the Z, go to X, and then to Y. So Z is the vertex, or X is the vertex, or the middle of the angle, and therefore this angle is 31 degrees. They want us to find XZY, which is here as the central angle opening to arc XY. Because we have a circle here, we see that ZX and ZY are congruent because of the definition of a circle. They are both radii and therefore are congruent. That's important because this triangle then is isosceles, and the isosceles triangle base angle theorem says the two base angles are congruent. So I know that angle XYZ is also 31 degrees. So I have 31 degrees plus 31 degrees equal to 180 degrees when I add those two angles to the measure of angle XZY, which is the one that I'm looking for. So all three angles in a triangle, according to the triangle sum theorem, equal 180 degrees. 31 plus 31 is 62, so we'll subtract 62 from both sides of the equation and find that the measure of angle X, I don't know why I wrote A, the measure of angle XZY is 118 degrees. Number 2. An isosceles triangle ABC, angle B is 117 degrees. And so these sides are congruent, and looking only at the large triangle, if ABC is 117 degrees, then BAC plus BCA would equal 180 minus 117, or 63 degrees. So then the measure of angle BAC would be half of that. And 63 degrees divided by 2 is 31.5 degrees. And this one is 31.5 degrees. I'm looking for angle AEC. And I'm going to change colors here to, let's go with this maroon. The next piece of this problem says that the bisectors of angle A and angle C will intersect at point E. So AE will bisect this angle, saying that this angle and this angle are congruent, and they are congruent also to these over here in angle ACB. In order to find AEC, this angle here, I need to know just that small portion on both sides. Well, that is 31.5 divided by 2 will tell us that 15.75 is how much any one of these little angles are. And let me get the highlight tool here. This triangle is now the triangle that we are talking about, AEC. And there is a 15.75 degree angle here and a 15.75 degree angle here, which together is that 31.5. So the measure of angle AEC plus 31.5 degrees equals 180, again using the triangle sum theorem. So we subtract 31.5 degrees from both sides of the equation, and you find that the measure of angle AEC equals 148.5 degrees. Example 3. In circle Q, the measure of arc RV is 110 degrees. The measure of arc VT is 50 degrees, and the measure of angle SRV is 55 degrees. The angle opens through arc STV. And the inscribed angle is half of the arc. So this entire arc here is going to equal 2 times the angle. Which is 110 degrees. So actually, arc TV being 50 degrees does not matter, since I'm trying to find arc SR. And arc TV is covered by the 110 degrees that I just found. And I know this 110 degrees. So 110 plus 110 plus the measure of arc SR equals 360 degrees in a circle. 110 plus 110 is 220 degrees. Subtract 220 degrees from 360 degrees, and the measure of arc SR equals 140 degrees. Example 4 has been scaffolded a little bit for you. When you see this question in the future, you may only see part C. Part A and B might not be there. Now, circle O is what we're looking at, and we see that angle HAM is an inscribed angle that opens up to a diameter, since it goes through center O. So angle A here is a 90-degree angle, which is half of the 180-degree straight angle here. And if that one is 90, the sum of angle H plus angle M is 90, since in a triangle there's a total of 180 degrees. So 90 degrees is the sum of the two other angles. If arc HA is X, what is the measure of angle M? This is challenging for students because I didn't give you a number value for arc HA, I gave you a variable. If I said this was 100 degrees, you would know the inscribed angle is 50 because it's half of 100. Well, here, instead of 100, I told you it was X degrees. And therefore, the measure of angle M is going to be 1/2 X degrees. So whatever X is, we're going to divide that by 2. The ultimate piece, or the final step, the thing that I'm looking for, is actually angle H. And we started off by saying the sum of angle H and angle M is 90 degrees, and angle M is 1/2 X degrees. So H is going to be 90 degrees minus 1/2 X degrees. The final practice question in this video is very similar to extended response, a BCR type question, where there's multiple parts to pay attention to. We're going to be looking at circle U for this question. It has a diameter RT, and that tells us that angle RST is 90 degrees. The measure of arc QT is 114 degrees. And if UQ is 9 units, is ST less than, greater than, or equal to 9 units is the question. Well, since this is a radius, RU is 9 degrees, UT is 9 degrees, US, or not degrees, units, and segment US is 9 units. So all of the radii have the same measure, making SUT an isosceles triangle. And since these sides are the same, these angles are the same. And one of those angles I can figure out from this inscribed angle TSQ, because I know the arc that the angle opens up to is 114 degrees. So I know that angle UST is half of 114 degrees, or 57 degrees. And if that angle is 57 degrees, and this is an isosceles triangle, this other small angle here, the other base angle, is 57 degrees as well. Using the the triangle sum theorem, 57 and 57 is 114 degrees total. So the measure of angle SUT is 180 minus 114 degrees, or 66 degrees. Now, using the side and angle inequality theorem, when the sides are not all the same, the larger angle opens up to the larger side, and the smaller angle opens up to the smaller side in a triangle. So the 57 degrees both open to a 9-unit side. The 66 degree angle is larger, opening up to segment ST. So ST has to be larger than 9 units, which is the other segment known, and so it is greater than. Part B says over here, if angle R is 5x minus 7, what is the value of x? Well, we need to know what is the measure of angle R so we can set up our equation. So I'm going to pull the larger triangle out here. We know this one is 90. We found this one to be 57. And so 180 minus 90 minus 57, or just 90 minus 57, since these two acute angles are complementary, is 33 degrees. I can set 33 equal to 5x minus 7 and solve. (33 plus 7 is 40, and divide by 5, x equals 8. Hopefully you're able to find the answer to some of these questions prior to seeing my answers. However, if you needed to use my answers, that's okay. Wait a few days, come back and give them a try one more time, pausing again and trying the question prior to seeing my solutions.